Yes, so this is a neat summary of everything that you need to know in geometry, right? Why do we study geometry? It's to understand space and structures. How do we do that? How do we understand space and structures is by making use of lines, angles, triangles, and then polygons. For lines, what you need to look for is perpendicular lines, parallel lines, and transversals. When you're talking about perpendicular lines, it's going to more often than not lead to adjacent complementary angles, which are angles that add up to 90 degrees. Under angles, you're going to be looking for adjacent supplementary angles, adjacent angles, vertically opposite angles, and then the fun angles. Fun angles come to be when you have a transversal that cuts through parallel lines, right? So that's the reason why I made the links between lines and angles. Then when we come to triangles, the two basic rules that we need to remember is the sum angles in a triangle add up to 180 degrees. The exterior angle of a triangle is equal to the sum of the interior opposite. We have right angle triangles. Under this here, two things stem from it is Pythagoras and trigonometry. Right, so now you can see our linked geometry to trigonometry. Then we have isosceles triangles. We have equal angles opposite equal sides, or we have equal sides opposite equal angles. Then we have equilateral triangles, which states that if all sides are equal, then the interior angles have to be 60 degrees. Or if the interior angles are 60 degrees, then all of the sides have to be equal. Still under triangles, we have similarity and congruency. To prove two triangles similar, we make use of the condition side, 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 or angle, angle, angle. And to prove congruency, we make use of one of these 5 conditions. Yet again, exactly as I said, that the midpoint theorem comes under triangles. And so the only reason I discuss polygons is because it introduces the new concept of theorems and converses. But the midpoint theorems come under, it's a concept that goes under triangles. And yeah, you can see exactly as I stated it here, the midpoint theorem and the converse. When you come to polygons, we need to remember properties, theorems, and converses and the difference between these 3. When we learn the properties, we need to learn it according to the sides, the angles, and the diagonals. So you can categorize your thinking like that. When you're learning theorems, look for the if and the then statements. When you're learning the converses, more often than not, it's just simply swapping the if and the then statement, right? We've learned 3 proofs and theorems for parallelograms. So when you're proving a quadrilateral to be a parallelogram, but I told you that there are more, right? So when you're proving rectangles, proving squares, proving rhombuses, proving kites and trapeziums, we've talked about that, but I obviously cannot put it on this diagram because it's going to be quite a bit. But we use the parallelograms theorems more often than not in grade 10, but you need to remember the rest of the theorems for higher grades. Right? Like I said, there's no proofs for the other theorems, only for parallelograms. And then we have the midpoint theorem that we've already talked about. And so this is a nice, neat diagram showing you everything that you need to know for geometry. And so if you go into the paper and you just keep this mental framework at the back of your head, I can guarantee you if there's a question that you cannot solve, your answer is on this mind map. But like I said, these theorems I can obviously not put it on the diagram. It'll be too much to put on the diagram. But I've already talked about theorems. So this is just to give you an overview of everything that you need to do. If you zoom in on each of these concepts, you know that you need to elaborate on it more extensively than I could even fit on this single sheet. All right, so just keep these frameworks at the back of your mind. This is the entire of grade 10 geometry displayed to you.